Butturin? Yeah, I did it. We talked about this beforehand to make sure I could pronounce it. Yeah. You know, I have to. I've been drinking. So, all right, take it away.
I can hardly interrupt that. I love Tom Petty, so we're gonna have to listen to all of this song. Yeah. So I don't usually get to talk in places with an upper deck, and I've always wanted to do this since I was a kid. How's everybody doing in the cheap seats? Oh, there we go. Yeah, that's where the party animals are, is in the cheap seats. So my name is Russell Butturini. I know the only reason that you guys are here is because this talk says $0, and you guys are in security, and all of you have infinite budgets. And, you know, so nobody ever needs to do anything on $0. But, no, this is real cool. I'm thrilled to be here. I'm actually from, Cookeville, or I'm from here originally and live in Cookeville now. And notice I didn't say Cookville, it's Cookeville. Kind of like it's not Maryville, it's Merville. Yeah, but I don't remember there ever being a security conference up here. And I know lots of people work in security up here and lots of smart people up here. And this is just awesome. And that is I did not really make slides that look like they're from Harold's Purple Crayon. We had some video difficulties, so yeah. If you if you can, these slides, I'll actually have a link where you can download them to here at the end of the presentation. Everything we're going to talk about today. So this is my least favorite slide. I hate talking about myself. When I talked to BSides Nashville, I gave a different talk, and I actually wrote a slide that said like what I'm not and listed out a bunch of things. But since I'm in Middle Tennessee and you guys are in East Tennessee, and most people don't know me here, I will actually reveal a little bit of information myself. I'm a senior enterprise security architect at a healthcare company in Franklin. I love when you go to conferences, people won't tell you where they work, right? But everybody knows you're just going to get on LinkedIn and find out if you really want to know. So feel free to do that if it's really that interesting to you. Most of the time I talk about red team stuff. I talk at a lot of security cons or write a lot of tools. This is going to be uncomfortable because this is not about attacking and breaking things, so we'll see how it goes. I do write a lot of tools, like I said, and I don't have a software demo today, so that's also going to be uncomfortable. I like a lot of English soccer. I like Manchester City. It's been a painful year, so please cut me some slack if you watch English soccer. So yeah, there's probably some Manchester United fans out here. So you know, but anyway. So agenda for this talk. I started trying to think about doing a different talk than what I did at BSides Nashville, just to keep some original material. And I went through a process, and I'm still going through a process of revamping the security monitoring where I work. And I thought, well, I'll just kind of tell a story. I'll tell about my experiences, and maybe it'll save you guys if I talk about some things I've gone through, some of my pain, save you guys some of the same pain. So we'll talk a little bit about philosophies around monitoring, the situation I was in and I'm still in. I did not know before I did a NetFlow talk that this was Cisco was going to sponsor this conference. So there are people here who know more about NetFlow than me. So I actually ripped several slides about NetFlow that probably had erroneous or things I made up on them out. Show you my monitoring architecture, some dashboard examples and things I do to look at my NetFlow, and then kind of integrate some threat intelligence feeds into your NetFlow analysis. So before we jump in the meat of it, I'm not Tom Petty, contrary to the intro music. I do not take a lot of drugs, or as many drugs as he does, before I get on stage. So I know I talk fast. If there is something that I'm going over too fast, or you have a question, just shout it out. Find the microphone over there. Feel free to ask questions. I'm happy to answer them. And I'm not an expert on packets, NetFlow, forensics. I failed the CCIE security lab 3 times and then decided that $4,200 was a little too much for lunch in Research Triangle Park, and I quit trying. So I know a lot about firewalls, VPN, routing, but when you start like dissecting packets and disassembling them and stuff, that's where I just like, let somebody else do it. So I want to start out with kind of what I consider the recent history of security monitoring part 1. This is my favorite movie, but there will always be a sequel because this stuff's always evolving. That was Mel Brooks' joke, as he called it part 1, because he figured he can do as many sequels as he wants. So attackers used to do this, right? We used to have exploit code, and we still do to an extent, but we had these network-facing services. We had exploit code. This, of course, is the MSO 8067, the granddaddy of them all, right? And you drop them, you get shells. So all of us ran out and bought in this ugly-looking IPS, and this is actually a Cisco IPS. So, yeah, so it had all this stuff on it, and it was great. We had a team of 5 guys watching it, and they told us all these things that were going on in the network, and there were these little red dots that meant bad things were happening, and it was awesome, right? So we looked at them, and this is what we saw. We saw a bunch of noise, and then so we had the 5 guys who were reporting to us that Apache exploits were attacking our IIS servers and things that weren't relevant. And we're like, okay, this isn't the best use of the 5 guys' time. We need to go and we need to buy this. This is Cisco Mars. So this is a historical talk since Cisco Mars no longer exists. But this was the screenshot I had handy when I wrote the top slides. So we bought an SIEM, right? And the idea was we'll buy this SIEM, and it's going to take events from all these sources. It's going to correlate them together. It's going to smash them all up into this one neat little ball, and it's going to be a lot easier to look at than all that noise just from the IPS and so forth. And the thing that we figured out is that the SIEM takes about as much effort to tune and write rules for and filter false positives out of than it was just looking at the other stuff. And then in addition to the 5 guys you had watching the SIEM, you had to have a 6th guy who understood the SIEM platform and also knew how to maintain it, tune it, and write the rules, right? So this was not so great either. So we started getting this figured out. More advanced SIEMs are easier to tune. They're simpler to manage and maintain, and they require less out-of-the-box tuning. And then attackers started doing this. They started just stealing our credentials. Now, where this is interesting is that something I think we were in a habit of for a long time in the security community or in industry was that we would use these technologies, and they were all signature-based, right? So we would always say we always rag on antivirus. Antivirus is dead, right? Why is antivirus dead? Because it's using a static set of signatures, and any little deviation off that static set of signatures causes the antivirus to fail detecting things. But really, if you think about it, that could be said of any security technology we're using right now. So if it's the case of an IPS, an SIEM, a next generation firewall, these are all based on static rules, definitions, and any minor deviation off those things means we may not detect something bad happening in our network. And so the second problem with that is we started cutting these things into bad and good. So we had a bucket of bad stuff, and that was all the stuff the IPS was detecting, the SIEM was triggering on as far as log analysis and things like that. And then we just sort of assume that everything else is in the good bucket, right? Well, then attackers start stealing credentials, and now this stuff that looks legitimate because it's good, I mean, it's a successful login, one try, now can potentially be bad. So let me tell you a story, not one about a man named Jed, but, I had to put a picture like this in because I'm from Cookville. So it's about my messy network. We have 3,500 users, and that kind of depends on who you asked. I've heard it's as high as 5,000. I've heard it's as low as 2,000. I asked last week, and nobody could give me a straight answer. So if you guys were in some of the talks across the street, the asset management program, yeah, we have problems with that. We don't know how many people we have, much less machines. We have about 350 externally facing things in the data center. It's a lot of web and mobile stuff, but there's, it's all in-house written apps. It's about 35 to 40 core code bases. We've got some SFTP, some SSH, some email, and other weird things that I'm sure you guys all have in your data center. We got 15 remote offices and a massive teleworker and road warrior base. So, man, it's a lot of stuff to monitor, and it takes a lot of time. So I started thinking about where we were, and we've gone through 4 SIEMs in 5 years where I work. We finally kind of settled on a combination of tools we like about a year and a half ago, and we got really good at logging everything. And you guys know, how many people have challenges just making sure that everything is feeding the event logging system and monitoring system logs? Does anybody have challenges with that? It's kind of dark, I can't see, but yeah, right? And, virtualization has caused a lot of this because everything is so stand it up, tear it down is very simple to build servers. It's not like back in the old days when we had to actually roll hardware in the data center and you had like a 6-month ramp up just to get a box online. It's, we can ramp up and ramp down real easily. We got pretty good at alerting. So after we got all the logs into our system, we saw the false positives, and me and my coworkers spent a lot of time filtering out, like, what do we really care about? What do we not care about? And so we got really good. We got the alerts we wanted. And what I found was that we really were not good at reacting when we got alerts. And I started thinking about why is that? And, you know, we would send emails to people. We use a lot of outsourced IT, and we would send emails to them like, hey, can you guys check this out? Or, you know, our system administrators, our database administrators, is this legit? And so I sort of came to the letter grade, and I gave us about a C minus where we were. And so I started thinking, you know, why were we so bad at this? And I realized that data is hard. People just didn't understand the stuff we were sending. And a lot of it boiled down to we were using a lot of correlation to make things really, really, really small and you know, smash 5 events into one like I was talking about. And oftentimes, if we were spent time ripping the 5 events back apart and looking at all of them individually anyway, when we really should have just been triggering on the first thing that happened instead of waiting for the first thing to happen and then match a pattern or timing of a second thing and then a third thing, then a fourth thing to correlate it all down. Then I started thinking we need to get rid of the good and bad buckets we had everything put into. We need to quit ignoring the stuff in the good bucket and just assuming it's good. And we need to treat everything as potentially bad instead of just this very static analysis and pattern-based analysis. And so I thought if we can find simple data points that we really care about, like a network connection, a flow, a single log entry, then we can use that and build pivot points down into all this other log data we need and build more focused and analysis programs. So what does this all have to do with NetFlow? And we'll get to that in a minute. So I told my boss all this. I was like, here's where I think we are. And he was really on a logging kick at a time. And his boss likes to talk about cyber, China, APT. He sent me something about the opium wars one day, and these are the things you get from C-level executives who read the Wall Street Journal. So I said, all right, this is what we need to do. And he said, you need to fix it. And this is about what my face looked like at the time. And so I said, all right, well, I need some guys. He said, you can't have any guys. He said, you can have these 2 guys, which is the people who already work here. This is me and my coworker Josh at BSides Nashville getting ready to talk. This is the entire technical security staff where I work. We have a team of 6, 4 of them are in our compliance. So this is our pen testing team, our web application testing team, our security architecture team, our firewall management team, and I don't pick something else and we probably do it. So you got to fix it with these 2 guys. And I said, okay, all right, that's fine. We need to buy some stuff. And he said, you get this much money. And I said, well, all right, great. So, let me see what I've got and what we can do with what we already have. So I started thinking, what's sort of the low-hanging fruit? What's the stuff I can start with to kind of get us where we need to be? So to get started, I chose 2 areas for monitoring. User behavior, and that's a whole separate talk in and of itself. And we actually chose a commercial product. I'll put in a plug here. I don't plug a lot of things from Rapid7. I actually detest that company horribly. Who's ever signed up, download a copy of Metasploit or something or Nexpose? How many times a day do the salespeople call you? Yeah, exactly. I mean, it's like you're in the agreement when you download a piece of their software. It says, I agree to have a salesperson call me 1 to 2 times a day for the rest of my life until I die. And but Rapid7 has a hosted product called User Insight, and it is an incredible user analytics platform. I strongly urge you to check it out. A lot of the things that we were talking about across the street this morning, if you guys went to some of those talks around lateral movement and user anomaly type things, then it does all those things out of the box. Very little tuning required. We get maybe 3 alerts a day out of it, and every one of them is something legitimate we need to check out. So I encourage you to check that out. But today we're not going to focus on that. We're going to talk about perimeter NetFlow. And the reason I decided to work with perimeter NetFlow is everybody, I talked about I had a lot of remote offices, but everybody backhauls their data through my data center. And then for the Cisco people, I enforce always on VPN with Cisco AnyConnect. And that is the greatest thing that anybody has ever come out with. You can't be on your home network. You can't surf the internet. You have to be on my VPN, and you have to have full tunnel, and you're going to backhaul it through all my stuff. And I'm going to see everything you're doing from this perimeter NetFlow. And it's also sort of the purest point that you can see the traffic. It's before any natting or firewall port changes or anything like that takes place. So it gives me the best perspective on the traffic as it's coming into the network and as it's leaving the network. And so I really like it. I really like it a lot for my analytics. I had a theory that if I could keep things in my data center, then I could contain them pretty well. Insider threats types things. It's when it's when things start leaving over the network or things start connecting back in from outside into the network. That's when I have problems. So this is where I want to start with my focus. Do I still need all my other stuff? Absolutely. But what I'll do is drill down onto my other stuff by analyzing this edge NetFlow, start with it, and then move down into my firewall logs, my Windows event logs, my database logs, things like that. So I'm not going to pretend to be an expert on NetFlow, but a little tutorial, and I'm sure some Cisco people will tell me this is all wrong, that are here, but it is a proprietary name by Cisco. It's been imitated into any number of other products. I collected off Palo Alto Firewalls, which has a pretty good implementation of it. I think pretty much any router switch has some sort of implementation of NetFlow, which is nice, but it's not exactly Cisco NetFlow, but it's pretty close, right? And it's basically just records of IP traffic, and you can store them in databases and analyze them and correlate them and do other things with them. There's two versions, version 5 and version 9. I chose version 5 because we had like a really, really old edge router primarily, and I wanted to go ahead and get started with that. And I'm a security guy. I'm not like a network technician or engineer, so all I really cared about is things like source IP, destination IP, source port, destination port, very basic things that are already in the version 5 records, and if they're smaller, I can store more of them on less space. So can be collected, like we said, from a number of different devices. Let's see how this shows up. That's probably a little hard to see, but this is just an example of what's in a NetFlow record if you've never seen one. This is a version 5 record since I'm using version 5. Source address, destination address, number of bytes. These are all things from a security's perspective we're interested in. Ports, TCP flags. Now, the thing that's interesting about TCP flags is they are a cumulative total of all the TCP flags in the session. So you actually have to look up the flags, and then there are hex values, and then do hex math to sort of reverse engineer which flags were set on a particular flow. Protocol, so IP protocols, TCP6, UDP17, ESP50, I think, AH51, so those sorts of things. I think ICMP1. I'm going to pretend I actually remember those things from the CCIE exam. Yeah, so these are the kinds of things as security people we care about and we want to be able to see. And the one problem with collecting this stuff from the perimeter is there's a lot of it because it's going to be pre-filtered by your firewall. So you're going to see a lot of things that maybe would never make it through the firewall anyway, but I think those things are particularly interesting because if somebody's perpetually probing you for a port that's known closed or whatever, you might want to observe what other things that IP is doing. So I started out, this man gave a webinar. He is crazy like that. This is John Strand, and this is his picture from Twitter. John, how many people are familiar with the Security Weekly podcast? Okay, yeah. Do any of you guys remember when John was on the podcast with Paul Asadorian every week and Jack Daniel? A little bit, yeah. John runs a penetration testing company called Black Hills Information Security. They do a bunch of stuff for me where I work. They do our pen testing. They do incident response. They do offensive countermeasures, hunt teaming, you name it. John's got guys to do it. Consulting at blackhillsinfosec.com. I don't work on commission for John. That's just a quick plug for him and a recommendation. But he gave a webinar. Gives a lot of free webinars, and he gave one with I'm forgetting the guy's name. I have it at the end of the presentation. Phil Hagen, and they gave a webinar on the SANS Forensics 572 class and this Forensics 572 VM that Phil built, and it already had this what's called the ELK stack. How many people have heard of the ELK stack? Let's see. Okay, a couple people. All right, so that stands for Elasticsearch, Logstash, and Kibana. And they have a webinar on using this VM to collect NetFlow into an ELK stack and do analytics on it. And so it's great. So it is a free virtual machine. You don't have to take the class to get it. You can download it from this link. And again, I will have these slides up. I have a link. They're on my GitHub right now, and I'll have a link at the end of the presentation to my GitHub with all the stuff we're going to talk about today. But yeah, I was like, this got everything already set up. It's free. It's got ELK set up. And you can sign up for webinars if you want to learn more about the ELK stack. Elasticsearch, if you're not familiar with it, is just a big NoSQL database that ingests JSON and indexes it for you. And there's a number of advantages to it we'll talk about. But if you want to learn more about it, there's a link to where you can sign up for a webinar. So I was like, this is great. I looked at our VMware environment. It's taxed, but I remember I have $0 to spend. but I had a Hyper-V lab environment that was pretty robust that was just sitting there collecting cobwebs. I was like, this is great. I'm going to take this VM. It's in VMware format. I'm going to convert it into Hyper-V. And that's pretty much what happened when I converted it to Hyper-V. It didn't boot and threw hardware errors and all kinds of things. And I spent half a day kind of troubleshooting it. And yeah, that was pretty much a waste of my time. But I was like, okay, this is easy enough, right? I can rebuild this from scratch, because there's just Debian and some other things. And I think I started with CentOS. So I started looking around, and there's a million walkthroughs on the internet on how to put the ELK stack together. And one of the best ones was actually on the Cisco site, and it actually was explaining how to do NetFlow analysis with it, from standing up the stack, setting up your patterns for NetFlow and your templates in Elasticsearch, to using Nginx to host your analytics front end and put some security on it so people can't erase your dashboards and things like that, which is great. So I was like, okay, this is easy enough. And I went through the whole thing. I built it from scratch. A few little quirks here and there, easy enough to, use my brain, which is Google, and solve. But I got everything up and running, and I was real happy with it. So, all right, first thing I need is I got to collect the data, right? So the piece that's going to collect your data is Logstash. Logstash collects, parses, rewrites, stores logs, pretty much anything you send it. It's got a native NetFlow parser and listener. It will send it to different databases, but they like Elasticsearch because it's bundled with the Elasticsearch family. All open source, and it's written in Java. And I have that part in bold because you guys might guess where this is going. So I got everything up and running. I got my NetFlow listener up. I got all my firewall ports open for my edge router. It's like, this is great. I'm going to flip it on, and it's going to be awesome. I'm going to get all this data, and this is what Logstash did. Logstash immediately sucked up 17.1 gigs of virtual memory, and the system collapsed and died. And so after, a day or so of trying to figure out what was going on, I just realized that basically Logstash is written in Java and it's a hog. So I called a friend of mine, and now I have to show you this picture. I hope there's no animal rights activists. So now I have a dead elk. Try Googling Google image search dead elk. You'll see some really interesting things. But I called a friend of mine. And I said, I know you were using Logstash, and this is the problem I'm having. And he's like, yeah, we had that same problem. We're not using Logstash anymore. He said, you need to look at FluentD. FluentD is it's written in a combination of C and Ruby. It is also open source, and it is specifically designed for no resource consumption. It's very, 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 very lightweight. So this is true. This is on their website. Vanilla instance. You can stand it up with no plugins or anything loaded. Just ingest logs, and it'll process 13,000 events per second on 30 megs of RAM. I mean, it is insane. They've got native. It's plugin based. They've got native plugins for NetFlow, and one of the things I really like that it does is it will take any string, you send it into its listener, and it will try to turn it into JSON for you. And one of the Logstash kind of does the same thing, but FluentD is better at mapping out key value attribute pairs. So it's really good. HA failover, it's got all that, and pretty much you can send it any type of log and it will convert it into JSON, and it will do it accurately, and it will do it with the right data types, which is really important because you don't want your integers going into strings and things like that if you're going to analyze it. So I was like, okay, great. Now let me see how this shows up. This may be hard to read. So I stood at FluentD. I put the same workload on it. And if you look at remember Logstash 17.1 gigs? FluentD 623 megs. Pretty different, right? And the CPU usage, it was actually doing something pretty intense at the time, but 2.6% of the memory on the system. I mean, you can't beat it, right? But that's, it's 4 cores, and it's basically just using 1 core out of the 4, and the system runs great. So I got my logging engine, my collectors up and running. I'm getting all this NetFlow. Right? So now I got to store it somewhere. So I still liked the E and the ELK stack. I like Elasticsearch a lot. One of the things I really like about Elasticsearch, remember I said I'm working on no budget, and Elasticsearch is a lot better at scaling horizontally than vertically. So it works better to put more small nodes in an Elasticsearch cluster than it does to just start throwing massive amounts of hardware at it. And the clusters are very easy to set up, and adding nodes and scaling is very easy to set up. Basically, if you put them in the same VLAN, you configure one string in the config file, start the service, the cluster nodes will all discover each other and build their own replication schedules and deciding who's the master and things like that. So that's great because I had limited amount of hardware, and I wanted to be as efficient as possible with what I had. If you send it JSON, it will index it. So indexing means it searches really fast. And so pretty much as the data goes in, it's there for you to search. So this is my very rough diagram of my architecture at this point. I've got FluentD running on a VM with 4 procs. This is all virtual and Hyper-V on one server 2012 host. I've got 4 procs, 8 gigs of RAM, and a 60 gig hard disk because FluentD really doesn't need to retain that much data. I'm sending data by HTTPS down into Elasticsearch. And that's one thing I should mention about Elasticsearch too, is it's all REST API based. So this is all just gets, posts, puts, deletes, to get data in and out of it. And then I created a second Elasticsearch node and put it in the same cluster. These are both 4 procs, 16 gigs of RAM. Each has a 500 gig hard disk. You can do more or less there, and I'll kind of show you some management tools for managing the data in Elasticsearch to optimize your space and your searches and things like that. But it's not a whole heck of a lot of hardware, and the title of the talk was accurate. In fact, it's actually a little bit under. I'm collecting about 50 to 55 million net flows a day from my edge on just this architecture right here. And I can repoint. Right now it's a manual process. I don't have these Elasticsearch nodes load balanced or anything, but all I have to do if this one dies is point at that one, and it just picks up and goes. So I got all this data. I got Elasticsearch stood up. All the data's flowing through FluentD. This is all working great. Now I got to look at it. So the first thing I want to do is I want to start putting some context around these events. One of the things that FluentD will do for you, and Logstash will do this too, is it will use the MaxMind IP database. Who's familiar with the MaxMind IP database? Okay. All right. Couple people, right? So they have a pay version. They have a free version. And this will basically map out the latitude and longitude of any IP address you send at it. They have a database for autonomous systems as well. One thing that Logstash does that FluentD doesn't do is it will actually use the autonomous systems database to aggregate data on the ASs connecting to you. And then Kibana is the preferred front end for Elasticsearch, analyzing data. It's this just beautiful web-based front end. It's got a very simple query language. You can drill down on the data. It's all very clickable, and it's got a beautiful user interface. There is a version 3, and there's version 4 is out. If you're going to try this stuff, I recommend staying on version 3 right now. It is more IT centric, so it'll do things like convert bytes to gigabytes for you and things like that, whereas version 4 is a more neutral, just numbers for data analytics. And then I followed the advice of the Cisco blog I read to start, and I used Nginx as the web server because it provides better real-time refreshes. So one of the things when my boss saw us, he's like, we need to throw this on a big screen TV because, we take customers by it and show them all the dots and blinking lights. Okay, whatever. But Nginx will keep your HTTP connections live, so as you're doing real-time refreshes with Kibana, it works well. And also, you can use the security features of Nginx because if you're familiar with Nginx, it's just a proxy for web requests, but I can actually block certain things, require authentication to things like the functions to overwrite my dashboards or modify my dashboards. So this way I was able to build things and give other people access to them without me having to worry about them erasing them or having to rebuild them when they screw them up and so forth. So I've got a few examples of Kibana dashboards. These are mine. And I would preface this by saying most of the Kibana dashboards I built I took like straight out of the SANS Forensics 572 VM as my base, and I just sort of modified them to fit my needs. So Kibana has some nice dashboards. So you have tables with lots of mathematical functions. I made D's in pretty much every math class I took, so I don't know what most of those things are. But so you have tables with totals and maxes and means and averages and how many and things like that. That's an example of some objects in Kibana, and this is all real NetFlow data from my network. You'll get some of my fancy photoshopping here to sanitize these screenshots. You see I took the pen and scribbled out the IP addresses. But you have time-based graphs, so you can see trending and things like that. All of these graphs are very editable using the built-in query language. which is very much like queries in Elasticsearch as well. You see, you can make, those are called not pie charts anymore, they're called donut charts because they have a hole in the middle. I just learned that the other day, which is kind of interesting. But that you can make pie charts in Kibana as well. But you see source IPs, source ports, destination IPs, destination ports. Those are things I like to track. Your environment may vary. You may want to build more specific graphs. You may want to build more specific queries. But these are just general macro level things that I like to track. Then this is the one that everybody just oohs and ahs about. Remember I talked about you could geolocate all the traffic? Well, this uses the MapQuest API, and it will take it's called the GeoIP data type in Elasticsearch, and it will parse it out, and it will draw it all on a map for you, and you can click those numbers, and it will drill down into this beautiful little view, and it will show you exactly which IPs are located which places, and you can zoom in and zoom out, and you can find things like why is that machine connecting to Russia. So again, the idea here is to build my starting level monitoring program. So what I'm wanting to do is, I'll start like looking at this dashboard every morning, and then I'll see, okay, there's a connection to Kazakhstan. That shouldn't be, right? And then I go and see what the destination IP was. Then I go back to my firewall log, like who talked to that destination IP? Does this match up with the times that the NetFlow record was written and things like that? So yeah, I mean, this is where I think it becomes very useful to get a more high-level view of everything going in and out of your network. And this is just a table. This is actually missing from Kibana 4, but this will show you the raw record, and that's very fuzzy. But this kind of shows you and gives you an idea of the stuff that's being written to the database. So you have the timestamp it was written, you have the city, the country code, destination country, destination region is their word for state. So you get the idea. Source IP, destination IP. So any of these things, you can build a table as you see them and think they're interesting and build your filters. You can drill down on them in Kibana, which is really, really handy. Again, I've looked at a lot of NetFlow tools, particularly commercial ones, and this is all being done with open source software. So, I mean, this to me is as good as or better than any commercial tool for NetFlow analytics that I have ever seen personally. And maybe you guys can tell me you have something better. But yeah, I mean, as far as handling load, the load I'm putting on it, and the information I get out of it, and the ability to do analytics, I think this is great. So let's see, these may not show up that well. Yeah, these kind of show up, but a little shadow there. Here's a real simple query that I use for Kibana every day. Basically, I look for a time range. I look for anything that's not going to the United States, and any over a megabyte of data transfer. So we don't have a lot of business that's international, and so I filter down and I try to look at all these connections where anything over a meg that moved in or out of the network, and it's coming from somewhere that's not here. But you get the idea. Also, I want to use this as an example of how simple the query language is in Kibana. It's pretty much true or false, and then a field in the database, and then you can do a match. You can do a range, like I've done here on the end. You can do wildcards. You can do regular expressions. So it's a really, really simple, beautiful query language for analyzing your data. Next one I got. This is when I look for a particular time range, anything that's not these standard ports that we see a lot of traffic moving in and out of the network on. So we do egress filtering, but you guys know how egress filtering is. You wind up having to open up stuff so people's push notifications work for their Apple iPhone, or some weird application that the CFO wants to use to get stock ticker quotes or whatever, right? I mean, that's how it goes. So I look for, any, and nobody also, and tell me if this is your experience, nobody can ever tell you what IPs it needs to go to, so you can, filter on just that at the firewall, right? It's always just, I need port 21373 open. Well, where do you need it open to? Well, I don't know. Well, where are you coming from? Well, I don't know. It could be anywhere, so. That's kind of how it works at our place, but we do our best. But yeah, so what I do is I filter out all the traffic that doesn't match like 80, HTTP, 443, HTTPS, FTP, SSH, or DNS, So anything that doesn't match those, that's interesting to me. And then of course, I added some filters for exceptions for things that I know are good going out as far as IP addresses. But yeah, I mean, I just hope this kind of gives you an idea. I wanted to include these as kind of example of the power of Kibana and how easy it is to drill down on data and create queries in it. Do what? 10 minutes. I got 10 minutes left? Oh, they told me I could run over. All right. So, but I'll speed it up. I'll take some more Tom's drugs. Let's see here. Okay, so I got to maintain it now. Elasticsearch does good job keeping itself healthy. Generally, you have two nodes. They replicate to each other. They do a great job. It's not a big deal. I've got a few commands I use to make sure things are right. This command is just a request in the API from the command line, and it will show you the health of your cluster, and it's actually just says like green, yellow, or red. And so green is good, everything's working. Yellow means that some of the data from one node hasn't replicated to the other, and red means one of the nodes is completely dead. So it's pretty simple to give it to like an intern or somebody to monitor for you. We just hired a guy I'm hoping to pass this joyous job to. This will show you all the indices on the server, and an indices an index is a collection of data. So Elasticsearch, what it does is it pushes data into a particular collection, and the way I have it structured, and it's easy to configure Elasticsearch to do this, or FluentD rather to do this, is FluentD will take the date, so like mine goes like year, month, day, and pushes it all into one collection. So every night when the date changes, Elasticsearch creates a new collection and just pushes the data for that day. You can easily manage. Curator is an open source tool, and I think that Elasticsearch may have taken it over now, but it lets you open and close indexes, delete indexes within a certain date range. So it's a great tool for managing your Elasticsearch data. It beats doing a bunch of curls and gets and posts to manage your data. But one of the things that I do to kind of optimize my Elasticsearch environment is I really only care, as I'm looking at that dashboard, about what's happening that day. So I do what's called closing an index. When you close an index, what that means is you've just excluded it from consideration in any searches you do against the database. The data is still there. So if all of a sudden I need to go back and say, hey, what was happening 3 days ago? I just go in, I send an API request, or I use Curator, and I reopen the index. And then now I can search that data again. But what I do is I just have a cron job that runs every night at midnight, and it closes the index for that day, and then it excludes it from any of my searches. Keeps my searches running fast, keeps my environment healthy, and minimizes resource usage on my implementation. So this was sort of a last-minute addition. Now I got to impress the executives. So I'm doing all this stuff, and they like the dashboards, right? It's great. So, but threat intelligence is hot right now, all right? Everybody's selling threat intelligence, and I've got a big repo of all kinds of data of what was touching my network and what was leaving my network, and so it's fantastic. I was like, all right, cool. I found this feed where this guy, Siphon1C, was building a program where he was taking threat intelligence feeds and inserting them into Elasticsearch, but it wasn't correlated against like any real data. He was just building a database with the dashboards we saw and stuff to show where different threats are happening in the world and trending and things like that. So I got the idea. I was like, well, shoot, I got all this data. I can build my own stuff. So I created a small script that would grab 3 or 4 threat intelligence feeds from Alien Vault, the Fiotobot tracker, some other things, and then at night it would actually run the scripts, and it will correlate them against the data, my NetFlow data, and generate me a report and kind of show me how many times each known bad IP had hit my network. These scripts are on my GitHub as well, if you guys want to look at them and certainly make suggestions, comments. I know they were something I whipped together in a couple hours just for doing this job. And actually, I'm pretty close to done, so we have some time for questions since you told me 10 minutes. He looks kind of intimidating with his 10 minutes there, man. He might jump up on the stage, give me the hook. So yeah, I came in a little ahead of time, but thanks for coming, guys. Phil Hagen, Sans Forensics 572 VM. I strongly urge you to check it out. Slides, the scripts I mentioned, my Kibana dashboard schema, because you can export and import data. They're just text files. They look like XML. All that is available here, github.com, TCS Tool, NetFlow. Some of my other projects are there. Feel free to look at those as well. And yeah, I've got a little time for questions. If you guys have some questions or comments, I'd love to hear them. So, yes, no, maybe. I can't see, so you're gonna have to like jump up and yell or something. Okay, there's a microphone over here. Okay, yeah.
What is your firewalls? They're obviously Cisco, but what version are you running that you're collecting this?
I have 3 sets of firewalls. Actually, I have 3 ASAs and 1 Palo Alto firewall. And what I'm actually doing, that's a good question. This data I'm collecting from my edge routers, which are Cisco. There's a 72 something and a ASR on the edge. I have 2 internet circuits. But Yeah, I'm using the NetFlow from my edge routers, not from the firewalls themselves. Although you can collect NetFlow from firewalls. The ASA has what's called SecFlow, which is a little bit different. The format it's in, you don't get some of the data, but you can actually collect data from the ASA. And also Palo Alto has their own implementation of NetFlow. Juniper, I think, has one as well. So yeah, good. Any more questions? You guys, there's a microphone over there. Feel free to jump up and ask. We got 5 minutes or so if you guys want to kill some time. No? Good enough. Thank you guys for coming. Really appreciate it.